Good day, sir. My name is Tanishan, and I'm going to explain question 5 and question 7 in this video. Question 5 asks to find the price of the exotic option by running a 200,000 of Monte Carlo simulation in Excel, and the risk-free rate is 6%, the sigma is 0.2, and the T is 24 months, S0 is 29, and the delta is 0 since the stock does not pay any dividends. Monte Carlo simulation is a method used to calculate the expected of payoff by taking the average payoff of certain randomly generated numbers. So first, we need to copy the information stated in the question at here, which the R sigma T is 24 months, and we need to divide by 12 and convert it in terms of years. And the S0 and the delta, and also the number of shares is 2000. Since the question asks to generate a 200,000 of numbers, so we need to use this function, which is rand bracket, to generate randomly any random numbers. Next, we need to find the z-score, which is the standard normal of the random numbers. We use this function, norms inverse of the previous number, and then we drag it down. Next, we can find the stock price at time t, which is 2, by using this z-score formula, which is S0 times with the exponential power of R minus delta minus 0.5 sigma squared times with t plus with sigma times with the square root of t and the z-score. So we can insert this formula in here. Since we have all this information there, we just calculate it, and then we will get the stock price at time 2. Next, we can calculate the payoff. Since the question mentioned that we will only exercise the option while if and only the stock price at time t is in between 33 to 36. So we have to insert this condition here, so which is if and only the stock price is greater or equal to 33 and smaller than 36, then we will exercise the option, and or else we will get 0 payoff. Next, we can calculate the expected payoff by taking the average of all these payoff. So we use this formula, which is average of these payoffs. Next, we can calculate the price, which is we calculate the price by times with the expected payoff with the exponential minus RT, and also we need to times with 2000, which is the number of shares. And so we will get the price is equals to 7,598 point something. Next is the question 7. Question 7 says that Tamara Mellon, a London-based fashion designer, is expecting to receive 100 million from a Japanese company as payment for goods sold in 1 year. Concerned about the potential exchange rate fluctuation, the company decides to hedge its currency risk by purchasing an option that grants the rights to exchange yen for pounds at a rate of 0.0055, which is the K. And also the information given are as follows, which is the spot exchange rate is 0.05, which is equals to the X0, and the sigma is 0.08, and the R for yen is 0.055, and R for pounds is 0.035. 7A asks to find the cost of hedging by constructing a 12-period of binomial tree using 2 different approaches, which is pound denominated and yen denominated. And question B asks to find the price of the option by conducting a Monte Carlo simulation of 100,000 of iteration using Excel. So to do so, we first state all the information given by the question here. Since this is a pound denominated, pound is expected to receive yen. Pound is selling, so we will do put for pound denominated. And then we need to find the U, which is using the formula of this one, exponential power of R minus delta times with H and plus with the sigma times with the square root of H. And D is similarly, but just need to minus with the sigma times with the square root of H. And the P, probability of going up, is calculated by exponential of R minus delta times with H minus D divided by U minus D, while the Q is 1 minus P. First, the question also mentioned that we need to construct a 12-period binomial tree. So we start the first one with the x0, which is 0.005. Next, we need to times this one with U and also times this one with D. So to get this one, to make it easy for our calculation, we just put this one, combine these two in one formula, and then doing so we can easily just drag it until the end of the period and drag it down also for 12 period. And so we will get this stock price, the exchange rate. Since we are doing a put option for pound denominated, we could start this backward. The payoff of a put option is the maximum of K minus S and 0. So we will just do insert it, K minus the exchange rate. And we can break it down for 12 period. And we will get this payoff at time 12. And we can start with this formula, which is also similar. Times this one with the probability of Q and this one in this cell with the probability of P. And then also we need to times it with the exponential of minus RH to know the price at the time t. So by doing so, we just drag it until the end of the 12 period, and also drag it down. So we will get this price of the put option. The cost of hedging for this, since the question mentioned that they want to buy 100 million of yen, so we just times 100 million with the price of put. So we will get 59,216. Okay, this is for the yen denominated. We do call option for yen denominated because we are using yen to buy. Since this is yen denominated, we need to convert all the information given into yen denominated, which is 1 over the 0.005, and also the K is also 1 over 0.0055. Then the sigma will not be changed, and in this case, the R for yen will become the domestic R, and the R for pound will become the foreign R. We use the same formula to get the U and D, and also the P and Q. Okay, similarly, we also start with the 200, and then we need to times U with 200 with U and 200 with D, and so on. This formula is similar as above, so we can just drag it until end of this 12 period and then drag it down for 12 period as well. So we will get this exchange rate. Since we are doing call option, we also need to start backwards. The payoff of call option is S minus K. So we can use this one to minus the K. Don't forget to log this. And then we can drag it down to get all this payoff. To calculate the price of call, we need to times this payoff with the probability of going up, and also this payoff with the probability of going down, and also we need to times all these with exponential of minus RH to get the price at time 0. Okay, we just can drag or similarly drag it until the end of 12th period and drag it down for 12th period as well to get this price of the call option. The cost of hedging is 1,100 yen divided by the K and then times with the call option. Okay, question 7b. Question 7b asks to find the Monte Carlo simulation by generating 100,000 of numbers. Similar to question 5 I explained just now, we also need to copy all the information from the question to here. Since the company is purchasing option to exchange yen for pounds, so we will use call option for the payoff. So similarly, we also use the same function, which is RND bracket, to generate 100,000 of uniform random numbers, and we want to get the z-score also. Use the norms inverse function. By doing so, we are able to get the exchange rate, which is using the same formula, which is x0 times with the exponential of r domestic minus r foreign minus 0.5 sigma squared times with t, and plus with the sigma times with the square root of t times with the z-score. So we can just insert this formula in here, and since we have all this information there, and then we can drag it down, we'll get the exchange rate at time t. The payoff will be, since we are doing the call option, the payoff will be the S minus K. Can drag it down, so we will get this payoff. Since this is Monte Carlo simulation, we will get the expected payoff by taking the average of these payoffs, and we will get the expected payoff will be this one. The price of option, we need to times the expected payoff with the exponential of minus RT. And doing so, we will get this is the price of the option. That's all for my video. Thank you.